Welcome back to my channel. So in this video, I'll be showing you guys how the general formula of differentiation was derived, how it was gotten. So let's say we have a function or an equation y is equal to x raised to the power of n, right? And we're to differentiate this using the first principle approach. That means for y, we'll substitute y plus delta y, right? And then for x, substitute x plus delta x, and then our power n. And let's open this bracket. So we'll have x, our first term, raised to the power of n, and then our second term will be n multiplied by x n minus 1, right, multiplied by delta x. Now our third term would be n bracket n minus 1 multiplied by x n minus 2 all over 1 multiplied by 2 times delta x all squared. And if we continue this expansion, this is from binomial expansion, by the way. If we continue this expansion, we would arrive at delta x raised to the power of n as our last term, right? So now let's subtract minus y, or let's subtract y rather, from both sides of the equation. So we have that y plus delta y minus y, this for our left hand side, and then for our right hand side we have that x raised to the power of n plus our second term rather, n x n power 1 minus 1 delta x plus n multiplied by n minus 1 multiplied by x power n minus 2 times delta x all squared all over 1 multiplied by 2, and then our last term minus y, which is x raised to the power of n. So this will cancel out this, and then we'll have this left. For our left hand side, y will cancel out y, and we'll have just delta y, right? So delta y is equal to x raised to the power of, delta y is equal to n x power n minus 1 delta x, and then plus this n minus 1 x n minus 2 multiplied by delta x all squared all over 1 multiplied by 2, right? Now we can leave out this last term, okay? We can leave out the last term. So now we divide both sides by delta x, right? This becomes delta y all over delta x equal to n x n power minus 1 delta x all over delta x plus n minus 1 x n minus 2 multiplied by delta x all squared 2, right, all over 1 multiplied by 2 multiplied by delta x, right? So now some things will cancel out. This will cancel out this, obviously, and then delta x is raised to the power of 2 here in the numerator, and delta x is raised to the power of 1 in the numerator, in the denominator rather. So we'll subtract the powers. We'll have this left. We have n x n minus 1, right, plus n multiplied by n minus 1 multiplied by x n minus 2, right? And then we'll have delta x. This is over 1, 2, right? And then next thing to do is to take our limit. And so if we take our limit, delta x tends to 0. So this becomes limit as delta x tends to 0 of delta y all over delta x equal to this. So if we substitute delta x to be 0, this cancels out, this becomes 0. In this first term, we do not have delta 0, so limit as delta x tends to 0 of delta y over delta x equal to n x n minus 1, right? So now we see that this, when we take the differentiation using the first principle approach of y equal to x power n, this is what we got as our answer, right? Now this is also equal to, right, limit as delta x tends to 0 of delta y over delta x is also equal to dy over dx, right? So we can say that dy over dx is equal to n x n minus 1 in this case, right? So this is our general formula for differentiation.